forth. So I'll hand it over to Sean here, and please interrupt Sean frequently as we're going through this. He likes to talk, and
Yes.
we'll keep this thing interactive. I'm going to dim this a little bit so we can see the...
Yeah, just to echo Dr. Wheaton's warning there, I can talk, and so the way to make this fun for everybody is to interrupt me frequently, ask some questions, we'll make it interactive, and hopefully have a valuable information exchange. So thank you for hosting me today. We've had a relationship with Utah State University for about the better part of a year now, and thanks in large part to the effort of Dr. Wheaton, and it's an exciting relationship that offers a lot of neat prospects for the future. So hopefully this will be just one more lecture in a long series of get-togethers. So today I kind of want to talk to you about the world of mapping, the world of GIS, Geographic Information Systems, and specifically how Google kind of falls into this realm. So I think we'll start out by just kind of framing the discussion, and I want to kind of create two bookends. The first is really the abundance of data we have out there in the world now, and specifically geospatial data. So how many of you have a smartphone in your pocket? Right, GPS sensor on that smartphone, presumably. It's got an accelerometer. It's got all of these different sensors that are generating data. Today, for the blimp lab, your peers are going to go out and float this blimp over the quad and take aerial imagery. Again, it's just data. It's being generated at an increasing velocity. There's lots of it out there. What the vignette I like to highlight is that there's 3,141 different counties in the United States. In each one of those counties, they know where their road data, they know where their roads are. They have data on where their sewers and their infrastructure is. And it's all kind of cultivated by a GIS manager or a GIS department who is the focal point for this great mapping data. The challenge is if you aggregate up to a regional level or a state level, you end up with what I kind of like to refer to as the balkanization of data. You end up with data spread across lots of different portals, lots of different front ends, lots of different SharePoint repositories. And the challenge is how do you take this data and synthesize it together? And not on like a ongoing long-term process, but how do you do this in a disaster response scenario? Or how do you do this when your state decision makers, your county level decision makers need this data in a hurry? They need to leverage it for decision making. This can be challenging when data is spread across lots of different areas and it's being presented in lots of different file formats. And really, I think this is a legacy of GIS and Geographic Information Systems being handled as specialized backroom technology. So in the past, it was okay to have the GIS people or the cartographer or the people who handled our maps. But the world is changing, as you know. So that's kind of the state of the union when it comes to enterprise. The other bookend for this discussion is kind of where we are as consumers. Today we are inundated with maps, and maps have become ubiquitous on all of these mobile platforms, whether it's the iPhone or an Android, it's a tablet or a phone itself. The consumer is being familiarized with mapping on a regular basis. So the one vignette I always like to point out is that when I was growing up, my mom could never set the television VCR timer. Like she always just played ignorant, I can't do it. And now 20 years later, the same woman hits a button on her iPhone and expects to see where the nearest Starbucks is in relation to her location. So it's like this massive paradigm shift, and I don't think she's become like technically savvy. I think this technology has just become so ubiquitous and the user experience has become so seamless that anybody can interact with it. And that's really where Google comes into this equation. It's really where my laptop locks up. So there we go. All right. It's going to be one of those days. I've upset the demo gods, apparently. So why is Google even in this space? Well, what does Google bring to this space? Google Earth, the application you're seeing here, is our 3D visualization software. It's been downloaded and uniquely activated by over 1 billion people, or on 1 billion different platforms. So a pretty tremendous amount of adoption. What's really crazy about that number is that this software didn't exist 6 years ago. So it's gone from no adoption to 1 billion implementations in 6 years, which is just amazing. We live in a world of big data and big numbers, but 1 billion is still a really large number. If you count 1 to 1,000, and I was going to do one iterative number every second, it'd take me approximately 17 minutes to get to 1,000. It'd take me 12 days to get to 1 million, and that's with no food or drink or sleep. It would take me 32 years nonstop to count to 1 billion. Maybe not 32 years for me, I'm a pretty quick counter, but the average person. So a phenomenal number, right? I don't know why this thing's lagging. Might be that IP sharing software, we might have to kill that. The next slide should come up after I'm done tap dancing. Oh well. Google Earth makes these KML and KMZ files. What does that mean? It really isn't important other than to say these are ordered text files. It's an open file format that's owned by the Open Geospatial Consortium. So anybody can use it, and it's really become, that's quite a bit of lag. It's really become the common currency by which people exchange geospatial data. So in the past, if you were working on a mapping project or you get lots of public-private partnerships, right, where a disaster response scenario kicks off like Haiti in 2010, and the military is collaborating with Doctors Without Borders and USAID, and all these people are coming together. But the question becomes, how do they share data? And in the past, that was very difficult because of proprietary file formats or things like shapefiles, which are fairly common, but not everybody has the software on their desktop to open a shapefile. KML has really become the great equalizer in that this file format is pervasive. And today, if I was going to send you the route I hiked last weekend or where I plan to travel this weekend, I might send that to you as a KML or a KMZ. This is going to be brutal. I think I'm going to have to kill that IIP sharing software. So, yeah, great question, and thank you for interacting with me. So I just don't tap dance. The KMZ is just a zipped version. So it's the Z stands for zip. It is the equivalent of creating a zip file. Actually, if you take the KMZ and just rename it zip, you can actually open it in a zip archive program. So, good question. All right, I think I killed that. Let's see if it improved. No, not at all. Trial and error, mostly error. Okay, cool. That's a little better. All right, cool. So Google Maps is this 2D visualization platform, right? What do I mean by 2D? I mean, it's often in a web browser. It's on your phone. We call them slippy map tiles. This is where I'm just kind of panning and dragging, zooming in, zooming out, interrogating points. That's the Google Maps platform. It's used over 1 million hours a day. So just in the hour I'm going to talk to you here, this platform will receive 60-some thousand hours of usage, which is just amazing. And what's really interesting about these numbers, and the reason I bring these numbers is not to just trumpet them in front of you, billion, million. It's really because I think they highlight this point. It's that we have 1 billion users for Google Earth and 1 million hours a day on Google Maps, and not one of those users has any loyalty to Google. They're not in any sort of contractual agreement where we are going to be their mapping provider. So because we live in this consumer threshold, we like to say that our users are 1 click away from going somewhere else. So if my mom were to look for that Starbucks on her iPhone and the user experience was unsatisfying, if we took too long to get back to her response or we gave her the wrong address or the wrong location, that's motivation for her and other consumers to go somewhere else. So the threshold by which we are going to be successful is how we can make that user experience fun, interactive, and how we can constantly innovate and iterate on the platform. So that's something we put a lot of engineering effort into. How many of you are familiar with Street View? Okay, cool. Street View is our program to collect high-resolution, ground-level imagery. It started as just a 20% time project at Google. At Google, engineers get 20% time. 20% of their time they can use to just innovate, be creative, do things outside of their prescribed work, work statement. And Street View started with that. A couple guys took a Yakima overhead rack on a car, and they cut a hole in it and put a digital SLR on top of it and started driving around. And that has matured to what you see here, which is a platform that is dynamic. And what's really neat about this car here is that it's got 15 cameras in that mast, but it also has LiDAR sensors, it has GPS, it has IMU. It also has odometrics on the wheels, so that car knows exactly how far forward or backward those wheels have rolled, knows how far left or right those wheels are slewed, and all of that data is being assembled. Tremendous amount of data is being brought together just so that when my mom looks for that Starbucks, we can show her what it looks like from the curb. And the user doesn't see any of that, right? Like all that kind of tertiary metadata is just part of making the user experience. Interesting note, the Street View platform collected 1/3 of all imagery taken on Earth in 2011. So, I mean, Flickr, Panorama, Facebook, everything the government does with commercial satellite imaging, 1/3 of all pictures were taken by the Street View platform. That's because every 60 feet, that car is taking a 52 megapixel mosaic. And we're driving in 60 countries, 15 million miles a year, we're driving with those vehicles. So again, it's a tremendous amount of effort, and really all that effort is to make our mapping platform a little more enticing so that the user will come to us. Because if we don't innovate and we don't iterate, somebody else will.
I've got a question.
Please.
So there's probably many other uses that the data could be put to, for example, the roughness of the road that engineers might be interested in that haven't in mind. How do you sort of make that accessible so that people could do that?
Yeah, it's a great question, and I don't think we have a great answer. I think those are the types of things that we're still experimenting with. One challenge is just the size and scope of the data, that the data set itself isn't something we could necessarily give to someone. So what we would do is look for ways that we could allow programmatic access to the data. So how could we let somebody else access the data and run algorithms on it in Google's infrastructure to learn these types of things? And we don't have an answer there. It's one of these things at Google where they kind of just head down the road, and quite literally head down the road and do the project, and then these are the types of questions that arise or are unforeseen. So in the years to come, you may see more of this data being repurposed for those sorts of things. But there's all sorts of really kind of interesting things you can think from this platform, especially as it becomes more mobile, more modular. You see here it was used on snowmobiles to cover the Olympic Games a couple years ago. Been mounted on a trike, and that's used primarily for amusement parks, college campuses. And then this indoor version is really interesting. This is becoming more prevalent, but it's doing a lot of museums like the National History Museum. Yeah, the National History Museum of Iraq. Not a lot of us are going to make the trip to Baghdad to go kind of take in all those relics from Mesopotamia, but by walking around that building with this apparatus, capturing that imagery, we can make an immersive environment that anybody can go interact with from their computer or their smartphone. So it's a great question. I don't have an answer other than the nonsense I just threw at you. So let me show you what this all looks like, right? So what Google's inadvertently done is we've created the world's largest repository of satellite imagery, aerial imagery, and ground level imagery. So this imagery spans not just latitude and longitude, but we've also tried to give users access to the dimension of time. So what I've done here is I've panned the Google Earth view over to the Clinton Presidential Library on the banks of the river in Little Rock, Arkansas. With the click of a button, well, first I'll draw your attention, and you may not be able to see it, but in the lower left-hand corner, it says this image was acquired on the 3rd of September, 2010. With the click of a button, we can actually dial back and use this historic imagery tool to see what this area looked like long before that building was constructed. So here's what that looked like in 2002. And then each one of the hash marks on this time slider represents a different date or point in time when Google acquired an image of this area. So we can literally just step through and watch the construction. 2002, construction begins. 2003, development is ongoing. 2004, it looks like most of the superstructure is done. Finally, by 2005, we see lawns are manicured. There's cars in the parking lot. So a really neat way to absorb all of this powerful spatial information with the click of a button. And the access to this sort of satellite imagery isn't new or innovative. It's really the ease of access that I kind of want to draw your attention to. Because if you went to the state GIS department here in Utah, they have lots of imagery they've taken over the last 50 or 60 years. The challenge is how could the average consumer get that, use it, interact with it? And I think that's what's really novel about this platform is it's become the great equalizer in that anybody can quickly install this program and begin to interact with spatial data. So the other component to this, and we'll try to zoom over here. So I'm going to zoom over to San Francisco, and I want to show you kind of how that street view has been integrated. So a couple things that are neat here. As I zoom in, we've always had this 3D buildings layer, which always gets better. A lot of this data is crowdsourced, so individuals make a 3D model of a building. They submit it up to what we call our 3D warehouse. Other users come through and say, yes, this is good, or no, this isn't good. And we kind of use a user-moderated system that allows buildings to be nominated for viewing in Google Earth. And so now any user can kind of tilt down from that God's eye view to horizon view and start to see these 3D buildings. And what we've added in the last 18 months are 3D trees. So you see these 3D trees here. We don't have worldwide coverage for 3D trees, but this was one of these kind of public-private partnerships in the sense that it turned out lots of universities had really rich repositories of tree data. They had been sending undergraduates out for years with a GPS unit and a tape measure to walk around and categorize the flora and fauna and assign a latitude, longitude, and measure the trunk. And that data was neat and interesting, but not a lot of people are going to interact with that data when it's in just a database or a flat file structure. But when we can kind of combine that with these 3D models of trees, all of a sudden people can interact in this virtual world with this vegetation. So I don't want to suggest that these models are the right height for the tree or that the branches are in the right location. But for the most part, we have a tree where there is a tree, and we have the species of tree that's appropriate and accurate. So about 80 million trees right now, not worldwide coverage, but an example of how data that lives in a database is kind of boring or unexciting can really be brought to life in this sort of environment. Yes, ma'am.
I'm wondering if we can find out what the age of the digital elevation model is. So for example, I work in an area where sand dunes have moved,
Sure.
and so the topography is wrong, and there are fake hills and things like that.
Yeah, that's a great point, and it's one of those things I don't think anybody ever envisioned from our side. Is when we started out down this road, we thought we'd take a digital elevation model, play with it, and you're absolutely right. The other place we've seen that is in strip mining in West Virginia. So I don't have a good answer for you today, and while we do a great job of providing historic imagery, we don't necessarily have this concept of historic terrain. I'm not at liberty to make any product announcements, but you can imagine that is something we're very interested in pursuing. Same thing happened with Google Ocean. Google Earth puts this thing out there, and people brought up a very good point that, hey, this is a lot of great land-based data, but you don't have a lot of bathymetric data for under the ocean. And so, about 2 years ago, we put a tremendous effort to take a lot of this bathymetric data, and I'll show you some of that. So we're always looking to the future. We have a really aggressive release cycle with Google Earth, where about every 3 to 6 weeks, we try to push out a new build of the software, usually in beta, and then we formalize that 3 to 6 months later. So there's always new versions being pushed out, and I encourage you to check it out because the noticeable shortcomings may be implemented in the future. So what I like about this, though, is the seamless integration. So I can go from those 3D trees and those 3D buildings with the click of a button. I'm brought into that immersive street view environment. And you can see here, this is pretty high resolution imagery. I can read this street sign. I can zoom and pan, and I can walk down the street. I can also click on something, and it'll try to give me the best view of that particular place. So I'll click on this house here, and we'll see if it takes me. So in its humble opinion, this is where it thinks the best place is to view that house. So all of this functionality is available to 1 billion people who downloaded it. It doesn't cost any money, and doesn't cost any money for them, but on Google's side, it took hundreds of millions of dollars of investment to bring all this together, and really it's just a little added feature that brings people to the platform. So that's kind of the point I wanted to make with those platforms, Earth and Maps, and now I'll try to show you some more demos and probably jump to the slides here for a second to get myself back on track.
Sean,
Sir?
what's the process by which Google decides which historic imagery to assimilate?
Yeah, great question. So we have, on the other side of that question, we're always bringing in imagery. So I think we published 20 million square kilometers in 2010. I think we published 45 million square kilometers of high-resolution satellite imagery in 2011. So our velocity is always increasing. What we try to look for are scenes that are high-resolution, full color, and we tend to prioritize areas that have dense population. So, we're probably going to update Salt Lake City more frequently than we update Logan. So maybe every 18 months we'll have fresh imagery for Logan, but we'll have Salt Lake City on more of a 6 to 12 month basis. But as you can imagine, all that's changing as this imagery is becoming cheaper to acquire, easier to get. And then from a historic perspective, it's usually partnerships that Google strikes with public organizations that have large repositories of data. So if they've already georeferenced it or at least tried to orthorectify it, we can bring it in and put it through our systems that will kind of seamlessly integrate it. One perfect example is Moffett Field out in, whatever I just did, I didn't mean to do. There we go.
White imagery from 30s and 40s is not likely to be on Google's radar.
Man, it's like you just were segueing into my next demo. You're hired, my friend. We're going to go on the road. So yeah, this is an example I like to show because in this case, if I zoom to Moffett Field, which is an old Air Force base, it's now the NASA Ames Research Center. I turn on the historic imagery here. Let me turn off the 3D building because that's going to give us a false interpretation. But I can actually dial back to 1948 here. It turns out they had lots of aircraft sitting around after World War II that had these reconnaissance cameras on it. And Google worked with the NASA historian who had this data. We georeferenced it, and now you can pull in and see World War II style aircraft parked on the apron of this base. And you can still see the giant hangar there, Hangar 1. For anybody who's been out there, it's this massive freestanding structure. And again, I can dial through and see that, 40-some years ago, in 1978, everything was blurred. It was a really weird time. Janis Joplin and the like. But now here, imagery from the early 2000s, and we see the same stuff. So some of that imagery makes it in there. It generally takes kind of a formalized partnership with Google because it is a lot of work to take those old photos and try to georeference them on landmarks that aren't there or intersections that just don't exist anymore. So if you know of some stuff out there, I'd be happy to point you to our folks internally who manage those acquisitions. And there's also some great World War II imagery of Europe, post-war Germany and France. I would highly encourage you to check out. It's neat stuff. So, good question. All right, where was I headed? Not there. So, not there either. So on this topic of Google Earth, Google Maps, one thing that we've tried to work with our partnership with Utah State is giving you guys a platform called Google Earth Enterprise. Google Earth Enterprise is basically some of the software we use to create the consumer version of Google Earth that we give your folks to run inside of a lab behind a firewall where you can start to publish your own imagery, terrain, and vector data out into your own Google Earth globe. So it's something we've been trying to get the grant pushed through for. The grant's finally approved. It's just a matter of getting some lawyers to sign off. But this would give you folks the ability to basically create your own Google Earth globes. And let me show you some examples of what that looks like, because it's kind of cool. Let me pull this up here. So this is a version that I run out of my lab in Mountain View, and with a few of my colleagues. This looks and feels like Google Earth, but the imagery here is not Google Earth. This is imagery that we custom built. And so I'd like to show you just one swath and the power of this. So we had some high resolution aerial imagery from an area out in Yuma, Arizona, which is always difficult to find for some reason in front of other people. It's no big deal to find when I'm just home. There it is. And so the power of this platform is you can kind of stitch together your own globe. So in this case, I'll show you this imagery. It's extremely high resolution, 10 centimeter or better in some cases. And as we zoom in here, you'll start to see, I can actually see the holes inside of these cinder blocks. I can see this guy's shadow. I can see the outline of a parking permit on this car. Really high resolution imagery. And obviously I don't have worldwide coverage for this imagery, but it's a scene I had. Maybe this was an area where I was going to do research or I was going to conduct some sort of operation. And this is a way that a globe can be stitched together for those sorts of purposes. So
you said that Utah State was getting one of these systems.
Correct.
What sort of a server hardware is needed to run this?
Yeah, so it's a great question. It's fairly intensive pre-processing software, so we usually recommend you put it on a Linux server with at least 8 processor cores. It's pretty flexible, so we have lots of folks who run this in a virtualized environment. As long as it's a 64-bit processor, you can get the software installed. The challenge might be just how long it takes to process some of this imagery if you don't have a lot of memory. And Dr. Wheaton could probably answer specifically where they would target in the lab to install this. But it's flexible in the sense it can be installed almost anywhere. I've, for instance, run Ubuntu virtual machines on my Mac, installed the software. It'll work, it just takes a lot of time to process. So.
Question?
Yeah?
Will USU's license for that cover multiple instances here at USU?
Yeah, that's what we'd like. I mean, we'd like to just let you guys have full kind of academic run of the road with this. And I'll talk about some other components to it. There's a piece called Google Earth Portable, which I think might be applicable, and we'd like to hit on that a bit in just a few more slides, if that's okay. I use it as a foreshadowing to keep people around so they don't leave. They know there's more to come.
Oh wait, I actually forgot. I need one student volunteer who is going to be bored of listening to Sean and leave his lecture early.
Can I go?
As a reward. Just need one volunteer to help Kenny. You'll do it? Yeah. All right. So you can sneak out at 11:30 with Kenny. When Kenny sneaks out to drag all the equipment out to the quad. Sorry.
So the other piece of this so Google Earth had that Google Earth Enterprise software around for a long time. It's the way that large defense and intelligence community folks kind of use Google Earth inside of their proprietary networks. It's the way state governments like state of Louisiana, state of Alabama, state of Maine take some of their GIS resources and make them available through Google Earth. But it is on-premise software, so it's very kind of anti-Googly in the sense it's an older software model. Where Google really lives is in this cloud environment. And what does cloud mean? Well, if you ask 100 people, you'd get 100 different answers. But cloud can mean a lot of things. It's really talking about distributed computing power. So using hardware and software in a more of a warehouse type environment. But there's people who will sell you a server to put in the back of your van and they'll call it a cloud. The way Google refers to cloud is very different. What Google realized early on is that we're a search company. 97% of our revenue is derived through advertising on that search. And so if you want to talk about how competitive the mapping systems are as far as being the user being one click away from going somewhere else, search is even less loyal in the sense that if Google takes too long to give you results, or if we make you dig 5 or 6 pages deep into those results, the likelihood is you're going to go somewhere else, right? Bing, and it's good to have that competitiveness in the marketplace, because what that drove Google to do was build this massive worldwide infrastructure of data centers. And so what Google did about 12 years ago, and was very forward thinking in the way they did it, is they created proprietary builds of hardware and software that were unique to their purposes. So it might surprise some of you to know Google's actually the 4th largest server manufacturer in the world. And you can't go out and buy a Google server. It's because we use all of that hardware internally. And we wrap it all with custom software, so custom builds of operating systems. And what this starts to look like is this massive distributed computing environment that has data centers all over the world, and everything's homogeneous. It all looks exactly the same. And that's the reason we can do things like deliver YouTube for free to a bunch of people. There's 18 minutes of full motion video uploaded to YouTube every second, which is just, I mean, we couldn't all go out to Best Buy and purchase hard drives fast enough to consume all those stupid cat videos, right? But because Google started out on this endeavor 12 years ago, they have such excess capacity built in that that's the reason they can serve hundreds of petabytes of satellite imagery and exabytes of video out there. But that infrastructure provides lots of interesting opportunities for parallel computing and parallel processing. And so what it allows us to do is it allows us to take lots of different processors and put them on different types of jobs. And one iteration of this is something we launched earlier this year called Google Earth Builder. Google Earth Builder basically productizes the pipeline that we use to take imagery from satellite companies, commercial satellite companies or aerial providers, and it productizes it in the sense that an end user can upload their imagery trainer vector data into Google's cloud and use that distributed infrastructure to process and store the data. So this feature is kind of cool, and we'll try to show off some imagery here that was collected last year, or 2 years ago, for the Blimp Lab here at Utah State. But what I'll do here is in this new version of Google Earth, you can see it if you download it at home, there's this Earth Builder option. If I hit Earth Builder, it's going to authenticate me. I logged in this morning, so it still has my credentials cached. But now what I have access to is lots of different layers of data that aren't available to the general public. So these are layers that I have access to based on my credentials, based on groups I'm a member of. Here's the Utah State University lab I want to show you. You'll notice I clicked that link, and in the lower left-hand corner here, I just gained a couple of layers. So let me back this off and show you what this looks like. So this is the coverage that we have in the Google Earth globe for Logan and for part of campus, it looks like. You can see this image was acquired back in, it looks like just August of last year. From a historic perspective, it looks like we have imagery going back through 2004, and then of course we'll have some of that real fuzzy black and white stuff from earlier. The earliest we have is 1993, and we only have partial coverage there. But because I'm using Google Earth Builder, I brought in some of these layers. So I'm going to click this, and now you'll see a couple different things here. One is some of the, I think it was NAEP data, or some of the state of Utah data. They had 1 meter resolution we got from the state. You can see that overlaid with Google's imagery. And the neat thing here is I can go back and forth between this imagery I uploaded and Google's imagery, so I kind of get the best of both worlds. And what's really cool is we took this swath that your peers and colleagues had collected over the quad. If I can find it, probably.
How do you make sure the images always line up? Because sometimes things seem to be offset.
Yeah, great. And it really, it's a pretty complex problem, right? Because this imagery is being acquired from lots of different places. How good were the sensors on the device that were collecting the imagery? From our perspective at Google, when we take in imagery from folks like Digital Globe and GeoEye, we actually do our own georeferencing and orthorectification on that imagery. So in that sense, we deconstruct the image pixel by pixel and try to do entity extraction and pattern recognition. So we try to do line up roads with roads. But inevitably, because this imagery was taken from some orbiting thing 400 miles off of the planet and at a different angle, sometimes those don't line up. And you can actually see that pretty well in this building we just brought in here. So I noticed it as I was running back and forth. Watch this kind of building. The position changes just ever so slightly.
That could be parallax.
Geographic projections that a lot of GIS people spend too much time.
Yeah, so we internally at Google, we reproject everything into WGS84, which is kind of our common internal projection. The Google Earth Enterprise system that you guys will have in your lab works with the Proj 4 open source library, so it's got 2,500 or more different projections where you can go from the state, you know, Richmond state plane coordinate system of 1938 that somebody thought was vitally important, that it's difficult, obviously, to bring that data in. And obviously, there's some inherent inaccuracy there, but, you know, whenever possible, we try to make things line up and look right. So I don't have a better answer. So this is some of the imagery that is actually acquired from the folks who did the Blimp Lab a couple years ago. And so in this case, I just stitched this in with the imagery from the state of Utah, but we can do the same thing. And actually, this imagery was really well referenced. So we can kind of jump back and forth here between what we showed in 2011 and what you guys collected from your Blimp just a few years ago. So look forward to taking some of the imagery you collect today. It's a beautiful day out there, and hopefully we'll get some good stuff we can bring back in and do interesting things with, and hopefully on a larger scale. So especially with the Aggie Air program and some of the things that your colleagues, neighbors, and peers are doing to collect imagery from drones, some of that can be really powerful when you can bring it into this sort of platform. And the real power of bringing it into Google Earth, right? Like why Google Earth? I think the value proposition here is that if you are dealing with kind of unconventional partnerships or ad hoc partnerships, like tomorrow there's, you know, a massive flood or some unenvisioned natural disaster, this is a common piece of software that people generally have installed, NGOs, private sector, commercial entities have installed, and so this is a really unique way to share data. The other thing I like about this is that from Google's perspective, we're very consumer focused. So we want to put imagery, terrain, and vector data in there that will generally appease, you know, 90% of people. So we're going to have, you know, some places like the shifting sand dunes, as we pointed out, our terrain is a little old. Sometimes our imagery is outdated, but generally we're going to try to collect high resolution satellite imagery because that's what consumers want to see. Like that's what my neighbor wants to see. They want to zoom in and see their house, and they want to see if that deck that they put on last year is there. Or they want to see the color of the car in their parking lot. But as you know, there's lots of imagery out there that's collected from different parts of the electromagnetic spectrum. So not just what the visible eye can see. And one I'd like to show you here, if I can find it, is this is some color infrared imagery from Montana. So again, I added that layer. I'm going to zoom over here. And this is imagery that we would never publish in the consumer version of Google Earth because it would really freak people out that everything was showing up red. But it's very powerful imagery, and it shows kind of the concentration of moisture in the soil. It gives us the ability, in some cases, to visualize heat signatures. I'll show you some of that in a second where this can be handy. But again, this lives alongside Google's imagery in this repository, so I can seamlessly go between the satellite imagery and the infrared imagery and start to kind of get some general visualization and awareness. So cool opportunities there. A couple other demos along that line I'll show you.
One question.
Please.
So can you bring in your own topography in this building?
You can, so no, topography right now isn't supported. It's on our roadmap. The Google Earth Enterprise system you have here will take in digital elevation models. You know, if you can build those out of your LiDAR point clouds or whatever. Yes, it's on our roadmap for this year for Earth Builder, but we're not quite there yet.
So if once we get the USU Google Enterprise,
Yeah.
wherever we are, if we can log in and get access to these data, can we download them also, or is it just viewing?
Yeah, so great question. We really look at Google Earth as the visualization platform. Now, there's lots of folks who also make it available from like a data warehouse, right? So I zoom in here to visualize it and consume it, but if I want the raw source files, you know, there might be another layer here that would then link me back to whatever data warehouse has that source imagery. So not like kind of out of the box, as we'd say, but there's lots of folks who do exactly that, is use this as the visualization platform that anybody can get into, and that becomes their gateway by which they can reach back into your database or your repository and download source data. Okay, so I want to show you a couple things here. So that is not what I wanted to show. So you guys are doing really cool stuff with Aggie Air up here, and your endeavor to collect imagery from drone aircraft. These present all sorts of really neat opportunities, right? So here's some black and white imagery that was taken off of a Global Hawk platform. In this case, this imagery is black and white, but it's fairly high resolution. What's really cool is that the sensor on this particular platform takes a variety of different shots across different spectrums. So hopefully here it's loading. What you're going to see here is the same area taken at the same time with some infrared imagery. And so what I can almost see here is the heat signature of where on the ground maybe an aircraft was parked, or whether or not the engine on this aircraft might be warm or cold, which can also be interesting to use from an analysis perspective. So lots of different ways to bring multispectral imagery into Google Earth and use it for visualization. Now, we don't envision this ever as being a platform for like robust analytics. So if you wanted to run, some sort of analytics against that raster, that's not really where Google Earth lives. That's where you'd want to go to a more fully vetted GIS stack, like something open source like GDAL or GRASS or QGIS or something like MapInfo or ArcGIS. One other cool thing here, this is some derived synthetic aperture radar. So in this case, the sensor, it was a very cloudy day. The sensor couldn't get actual electro-optical imagery, but what it could do is bounce a bunch of trons through the clouds and then collect the return. So in this case, we can kind of see where this road is opened or where it might be blocked just based on those radar returns. Now again, this would not be pleasing for the average consumer. They would not want to log in and see their home look like this blurry television screen, but obviously for some of your use cases, for defense and intelligence, for homeland security, for disaster response and preparedness, you can see how this sort of imagery could be very useful and very beneficial. So that's kind of the gist on Google Earth Builder. Kind of a cool platform, lots of interesting things being done there. It provides some interesting opportunities. So one of our first folks to jump on board there was Frederick County out in Virginia. Let me try to refresh this page. I think I have some resolution issues. What I want to show you here is how they took a bunch of their GIS data from their repository inside the county and made it available through Earth Builder, which is kind of cool. So they have lots of GIS data, and I think, and I'm not like showing this to throw spears, but I'm showing this to show how Google has been so disruptive in the field of mapping and in the field of GIS that we've really forced other people to focus on the user experience. So what I'll show you is with the click of a button here, I'm going to engage the imagery layer that this county has put out. Oh, that's my problem. It's not actually full screen. There we go. So this is actually loading, going back to their ArcGIS server and pulling this imagery out as a web mapping service or a WMS. And you'll notice this isn't my laptop. This is actually just taking a long time because in the past, this was the status quo for mapping. It was okay, and people were very comfortable hurrying up and waiting in the sense, right? Like getting everything set up and then clicking the buttons and then going out for coffee or letting things process. But increasingly, that expectation doesn't jive with what consumers expect. So the difference here is when we take the same sorts of layers and we bring it into Google Earth Builder, with the click of a button, now I'm interacting with this imagery that's coming directly out of Earth Builder. It's the same source data, but it's being served up by Google's worldwide data center infrastructure. And that's what I think is really unique, is what Google can do as far as delivering lots of data in very fast ways across geographies. So I only grabbed a screenshot, but one thing I wanted to draw your attention to is Google always partners with Northcom, NORAD to do this Santa tracking every year, right? So this was a screenshot from a year or so ago where kids can just log in and see where Santa is on the 24th of December. What's really neat about this is this platform absorbed 1.6 million queries per second at its peak load on the 24th of December. So 1.6 million times a second, people around the world were updating, refreshing, trying to get Santa's most current vector and location. What's really interesting about that is enough capacity that it would have absolutely crushed anybody's on-premise server. Even if you were using Amazon's cloud, which is very robust, you would have had a whole staff that was provisioning new servers and setting them up and load balancing. The neat thing about what Google has really done is that this sort of thing can be served, and there's really not a lot of thought that goes into it because this worldwide infrastructure of computing distributes the workload evenly and does really impressive things. So, and it's also that you can watch cat videos on YouTube that much quicker.
Where does Google sit with respect to other people providing cloud services in terms of size?
Yeah, so it's all different, right? Like I actually use Amazon's cloud quite a bit for some side projects I do, just because it fits for me in the sense that I can stand up a Linux server or a Windows server in Amazon's cloud, and Amazon has a very robust cloud. What's different about Google's cloud is it's a little more contained in the sense that we don't let you kind of like stand up your own virtual server, but we have lots of programmatic access to Google's cloud. And I guess that's where I'd kind of point you to a cool little website. Google's very API driven. What does that mean? We're application programming interface. We want to provide really cool platforms and really cool software, but we don't want to limit you or the way you interact with that software based on the user interface that we envisioned. So Gmail is a great example. We put out Gmail, 300 million people use it, but there's other ways people want to use Gmail. And so for those purposes, hold on, sometimes my mouth goes faster than my fingers. Periodic table of APIs. So what we try to do is extend all of this programmatic access. So that is not what I wanted. Did it go away? That's a picture of it, but I really want the real thing. Google API. Maybe we just got so many complaints that it was blurring kids' vision of what the real periodic table looked like that we took it down. Google's a dynamic company. They change things overnight without telling me all the time, which is good. It keeps it interesting. Yeah, it looks like they have pulled it down. So regardless, what I liked about this approach is it really highlights how Google is a company of building blocks, in that all of these services that we offer, whether it's Gmail or YouTube, it can all be accessed programmatically. And you can think of that as being a giant building block that you can assemble for your needs and purposes. So, we have lots of folks who do interesting things with field data collection, right? So they want to put people out in the field and give them a mobile phone and let them take surveys or collect observations. So they'll kind of come here and they'll look and they'll go, okay, well, I could use Google Latitude, which is kind of our geolocation platform for mobile. I could combine that with Google Fusion Tables, which is our kind of spatial database in the cloud, and then I could combine it with Google Earth so that back in a command center somewhere or back at our operations center, people can visualize all this data as it comes in. And those are use cases that Google never envisioned and we would never put together. But because we provide these as building blocks, lots of different creative developers can come in and connect these pieces.
So that approach is great, but how do you guarantee the reliability of a building block that you've sort of grown to depend on?
Sure.
Somebody else says, you just showed an example of where the periodic table is.
Yeah, the periodic table demo is gone.
I depended on that then I'm suddenly.
Yeah, and the periodic table, I mean, that wasn't an API. It's the same front end as here. It's just allowed me to visualize these as building blocks. I think what happened is there's now so many APIs that there weren't enough squares on the building block that's a complaint we had, is that we started to have a periodic table, but then we started with all these supplemental tables underneath, which kind of lost the original intent of staying with the periodic table. And it's a great question. These platforms do change. Google's not a company that's afraid, we're never married to technology in the sense that we're not going to be kind of constrained by legacy architecture decisions. So yeah, if some of these pieces of software are no longer applicable or people aren't using them in kind of a critical mass, Google will begin a process where they deprecate. But usually it's a 2-year process where Google will say, okay, we're going to stop development on this platform, but it's going to be around for 2 or 3 more years. So we try to give people time to migrate. But again, a lot of these services are all provided for free. So it's we give people time to get off the free platform. There's a paid component to some of these services, and in those cases, it's wrapped with a service level agreement. But yeah, I would definitely recommend doing due diligence if you're going to create, some business integrity system that you need to live off into the sunset. You might really want to take a hard look at these platforms and where they make sense. But people use them all the time, and the nature of the internet and the nature of now tablet computing and smartphone computing is that the landscape is changing so frequently that we try to keep up and re-release, redevelop, and revision platforms as necessary. So, one I will show you is the Google Fusion Tables. Let me pull that up here. So Google Fusion Tables, what the heck is it? It's a spatially aware database in the cloud. What does that mean? It means that it basically provides a database like you would use on-premise, like a SQL database or a Microsoft Access database, but it's all in the cloud. So you can access it completely through a web browser, and it allows you to do really interesting things with data, and you're not constrained to whatever software you might have installed on your machine or whatever hardware you might currently be running. So in this case, I went out to the USGS and downloaded all the earthquakes that had happened in the world since 1978. Here, I clicked the wrong data set here. That's actually the other data set that I'm going to use as my punchline. But so here's that data set. It's 175,000 rows of data, all with a latitude, longitude component, the year the earthquake happened, the month, the day. It's all in a web browser, right? So I didn't have to install any software. It doesn't matter if I'm using a laptop or a desktop or a tablet. Push this data up to Google, and now I can do interesting things with it in Fusion Tables. So with the click of a button, I can visualize this data as a chart, as an intensity map, as a timeline, or more relevant to our purposes today, we can visualize it as a map. So here's 175,000 points all on a Google map. And maybe I don't want to visualize these as individual points. I can create kind of a generic heat map, and that shows me the relative intensity of earthquakes since 1973. what's really cool about Google Fusion Tables is that you can very quickly mash up disparate layers. So the other layer I pulled up inadvertently ahead of time is this second layer you're seeing here, which is the location of nuclear power plants around the world. So 2 data sets that lived out there on the internet. They were Excel spreadsheets or they were text files. And certainly somebody with the right skills, the right software, and the right hardware could take that data and bring it together and make a map. What's really interesting about platforms like Fusion Tables is that they have lowered the threshold by which people can enter into this sort of rudimentary analysis. So anybody now can take data, upload it into Fusion Tables, and hundreds of thousands of times a day, that's what, middle school students, high school students, researchers, businesses, that's what they're doing is they're using this free platform to try to visualize their data spatially and also visualize it as graphs and charts. So really cool capability, and it's easy to use and fun to use. So I would definitely recommend kicking the tires on it. As with all things at Google, it's got its quirks and it's got its nuances, but generally it's really easy to take a spreadsheet and push it up there.
So it's in beta right now. Are there any plans for, is it going to be, what's the timeline for full development of it?
Yeah, great question. So there were some architecture decisions made with Fusion Tables initially that if they were going to make today, they probably wouldn't make. And so we're actually in the process of leaving this in beta, but there's some kind of co-development on a Fusion Tables 2.0 type situation. The biggest challenge is that because of some of the architecture decisions they made, this thing would only handle like 10 million points at a time, which for the average user is no big deal because we just don't have 10 million points of data. But that scalability created issues. And so actually it's getting rolled in with Earth Builder. Earth Builder will be kind of we'll have a vector and a raster component to it. So it'll do imagery or points, lines, and polygons. And that migration is happening this year. So over the next few months, we'll see that development mature. And the cool thing there is it's not going to be constrained by some of these decisions. So 100 million points, 200 million points, it's all possible. And then possibly we could use this same infrastructure to run analytics against those. So nearest neighbor type algorithms, you name it, there's lots of interesting possibilities because it'll all be exposed as an API. So more to come on that. A couple other things I'll point you toward.
What about,
Please.
referencing and citation and metadata?
Yeah.
How do you, can you access that along with the maps? Or?
Yeah, so this map and the way the platform works is that it's totally interactive in the sense that the user can decide what to expose via the map. So in this case, they've made the points clickable and they've decided this is what should go inside of that balloon window. But any of the attributes that are exposed through the table or through the spreadsheet can then be brought forward to.
But other than attributes, I'm talking about data sources.
Sure.
And things like that.
Yeah, so I mean, this is, let me think. Again, those are decisions that the user can make when they decide what their interface is going to look like. So let me see. This was one I threw together with Bureau of Land Management data. In this case, the user doesn't even know they're using Fusion Tables. I just took a bunch of Bureau of Land Management data and I attribute it by saying here it is. And now that I look at it, I didn't do a very good job of saying when I pulled it from their source. But with with changing one line here, I could change that grazing range allotment from just saying that to maybe having a source. Or actually, I think I made it clickable too, so you can actually go to that link and see the data I used. But again, we look at this as a platform, so we would expect that whoever's using this would find their own way to kind of surface that data. The platform supports it. We just don't have like any built-in widgets that would necessarily give you sourcing and metadata type of view. So, okay, what was I going to show you? Oh yeah, I want to show you a Google Earth Engine. This is kind of a cool, unexpected success within Google. So back February last year, just about 13 months ago, ahead of the COP16 climate summit down in Cancun, Google started looking at how we could use our data center infrastructure to do raster analysis, so to do change detection analysis on imagery. And so what we did, we launched it under this Earth Engine platform, but we went back and took all of the Landsat data that had been collected in the last 25 years and brought it basically into that Google Earth Builder platform. But once it was in there, we could start to do some interesting analysis against it. And what's really interesting is it took a lot longer to actually digitize a lot of this. A lot of this imagery from 25 or 20 years ago was still on microfiche tapes. And so there was a major effort underway to, hundreds of petabytes of data to bring it all together. But now that it's all in one place, you can do interesting things against it. So for instance, running some basic NDFI analysis over the Amazon, they detected like more standing groundwater than anybody had ever known had existed previously. And they were able to show deforestation in South America to a degree that no one else had really been able to show before. So this is an interesting platform. We're right in the process right now of releasing some APIs for this, so that would allow researchers to run their own analysis on this data, or would allow researchers to upload their own data and then do collaborative analysis between the data Google got from Landsat and the data you have. So lots of interesting possibilities for this going forward, especially in the commercial space. What's really interesting is how large commercial companies are now using remote sensing to make business decisions. So, pretend we live in a country where there's like 2 really large hardware franchise conglomerate things, and like these giant, we'll call one dwelling warehouse, and we could call the other highs. And these two are in this fiercely competitive situation where they want you to buy your home improvement supplies from them. And so they literally fly aircraft 300 days a year over each other's parking lot to do density analysis at different times of the day to see, how's that store in Sioux Falls doing, and should we build one across the street from it? But it's that sort of analysis that they're doing on a very kind of onesie, twosie basis right now, that cloud computing, the real promise of cloud computing is that some of that could be done in real time, some of that could be done in the background. We could actually use these self-learning algorithms to just basically, the computer could start telling them when they should build a new store based on some parameters or based on some of the indicators that have been loaded into the system. So it has dramatic potential. Another interesting thing, how many of you have ever seen Google Goggles? Google Goggles is our image recognition platform. So some folks are working on this where you basically take a picture with your Android or your iPhone and it tries to do pattern matching on the photo. So it works really well with products. For instance, if you were to take a picture of a Coke can or any sort of product in the store, this does a really good job of coming back and saying, here's a bunch of other images that look just like this. Based on what I know, I think this is Heinz 57. It also works well with books, barcodes obviously, artwork. But this is also a self-learning algorithm. So every time you get an image back, you can optionally, you can tell Google if it was right or wrong. And all of that's learning in the background. Well, when you start to think about how these pieces could be combined, right? So you got Google Earth Builder, Google Earth Engine, and Google Goggles. You start to envision this world where you could take your raster data, upload it into Google Earth Builder, have change detection analysis running on it inside of Google Earth Engine, and then have, we're not at a point now where it could necessarily match features from satellite imagery, but certainly it's possible in the future. There's even talk that this platform could mature in the 18-24-month time period to recognize individual species of flora and fauna. So you just take a picture of a leaf and it'll go back and try to give you a best guess as to where that leaf came from. But then now you can imagine, so your data's in Earth Engine, it's doing change detection, and now maybe you just get a report of, I don't know, if you're studying airfields, right, or you're studying ports, it could tell you what ship had left overnight or what aircraft had moved since you last took an image. Really interesting technology that has been kind of the product of science fiction, and if you watch The Bourne Identity, they'll convince you the government can do that today. I will assure you they cannot. But this sort of technology is enabling that sort of functionality and really has some big promises for the future. So lots of cool stuff. The only other thing I wanted to show you guys is I just wanted to make kind of an interesting point. I recently was doing a side project where I needed to have a bunch of geodata referenced by humans, right? And I just needed them to come through and basically give me a heads up, or was this a good geocode or was it not a good geocode? And there's a couple things I found for this that were just amazing to me. One is called Odesk. This is an outsourcing desk. This isn't a Google product or anything like that. But what was amazing about this is that I could hire third world contractors to do really crazy things for absolutely pennies. It was unbelievable. So I had one woman working for me for 67 cents an hour in the Philippines. She would do 40 hours a week. And she's like, to this date, the hardest worker I've ever worked with. And she set the price for her time and labor. And what's really interesting is I was able to hire some really powerful GIS professionals. So I found a guy named Ashrafal. Ashrafal teaches, he's got a master's degree in GIS and teaches remote sensing in Bangladesh. And he worked 40 hours a week for me over the Christmas break for $3 an hour. So it's absolutely amazing what's happening in this world where globalization is here and now. And I'm not to say that you're going to go out with your new remote sensing or GIS degree and be competing against these people, but this is kind of the world we live in, is that this is a great way to outsource the making of a map, which enables us as GIS professionals to do other more interesting algorithms and analysis. So the other part of this that was crazy is an Amazon product called Mechanical Turk. If you haven't played with it, definitely go check it out. Mechanical Turk is basically doing the same thing, but it does it on a per transaction basis, which is pretty crazy. They created this concept of a human intelligence task. They have 500,000 people on this platform at any given time, and you feed in a human intelligence task, they do something, you get the result, you either accept it or reject it. If you reject it, you don't pay for it. If you accept it, you do. So I was using this for entity extraction. I sent a bunch of news articles out to this system, and like I could send 10,000 at a time, and it would take 5 minutes because all 500,000 of these people are bidding on the job, and I'm paying a penny a piece. So I worked with some guys at GOI recently who took a bunch of imagery they had collected over Arizona, and they wanted to just test this platform. So they said, okay, we're going to cut this huge quad of imagery into small 512 by 512 pixel images. We're going to push it up to Amazon Mechanical Turk, and we're going to ask a simple question. Is there a trampoline in this image? It was a residential area, so they wanted to know. And they pushed all these jobs up. It was something like 12,000 jobs. They were completed in a matter of minutes. And it came back, and they knew exactly then which parts of the image had trampolines in them. And so basically, they took an entire residential area, and they were able to identify where all the trampolines are. They turned around and sold that data set to some fly-by-night insurance company that's now going to go knock on all those people's doors and try to sell them, trampoline insurance. But I think what's really amazing about that is even if you don't have a supercomputer, because we could probably write an algorithm that would go out and do pattern recognition on imagery to try to extract things like swimming pools and trampolines. But with Mechanical Turk, we can do that for a penny a task. And what was really interesting is that the GOI guys continued to play with it, and they dialed down where they weren't paying anything for the task. But because Mechanical Turk is this kind of social network in a sense where you get a rating based on how many of your tasks you complete are accepted, they ended up getting basically the exact same results for free. It just took twice as long, so it took like 26 minutes on the same data set, and they didn't pay anything for the task. So just amazing forces that are happening out there in the world that may or may not be on your radar. Lots of interesting ways you could use this for your research and even your surveying. So check it out. All right, last thing I want to close with is a product we call Google Earth Portable. This is something that we're excited to pass off to the folks here to use in the lab. But the concept with Portable is you can draw a polygon around the Google Earth globe, extract all the imagery, terrain, and vector data inside of that polygon, and create a local cache, a full Google Earth environment in a situation where you have no outside connectivity to the rest of the world. There's lots of cool devices on the market now. I'll pass this one around. I showed this before. But this is a tiny plug computer. These things are $100. You buy them offline. It's a small Linux server, has a Wi-Fi hotspot in it. I plug it in the wall here. It's broadcasting a Wi-Fi server that you can connect to. What I did is combine that with Google Earth Portable, and now we have basically a Google Earth Portable capability right on a device that could run out of the cigarette lighter inside of a vehicle. So I sent 5 of these to Sendai last March after the earthquake and the tsunami with search and rescue teams from Virginia and California, and this allowed them to have a full Google Earth environment in the aircraft as they flew over so they could start familiarizing themselves with terrain, with different geographic features, with the coastline. And then once on the ground, they just plug this in the cigarette lighter inside of a car, and they're driving around broadcasting a Google Earth globe as you get these kind of mesh networking ad hoc relationships where one search and rescue team rendezvous with another search and rescue team. They can share their geospatial data all through handheld devices connected on small things like this. So we think there's lots of opportunity to do cool things with Google Earth Portable in your realm in academia and specifically in field data collection. So how this could augment the way you go out and collect imagery. You could be doing that on a handheld device, looking at the imagery that was taken last year and then making dynamic decisions about where to collect this year or what needs to be collected again. So that's Google Earth Portable. We're hoping to pass that off to you guys as part of this grant for Google Earth Enterprise, and would love to see you take the platform and run with it and do interesting things. So I appreciate you taking time. Overall, why do I think you should care? Google's out there. We're very consumer facing. People use this stuff every day. The cool thing about that is I see more interesting use cases of Google Earth just by going around and talking to people. And I see use cases I never would have envisioned. And people do interesting things with the platform that were never expected or anticipated by the folks at Google. And I think that's one benefit of having such a large corpus of users, developers, and innovators out there. And I will say that don't be intimidated by this stuff. It is a bit technical, and those APIs can be a bit challenging, but I'm an engineer at Google, and I got my undergrad in criminal justice from Michigan State. So if a fuzzy major dumb kid from a Big Ten school can kind of master this stuff, I'm very confident that you all can find ways to make it work for you in your research endeavors and beyond. So we have a few minutes for questions, and I'd be happy to show you other demos if they come up during the question and answer portion. Sir?
For Google Earth Engine, you said
Yeah.
you guys got some older Landsat data that wasn't available. Is that available to download and use?
So that's part of our launching that API is how we're going to make that available. It's lots of data. It's terabytes, if not petabytes, for that old stuff. And so no, not right now, but that's all part of our initiative to launch the API is making it available programmatically for folks. But no, yeah, it's kind of like the Street View stuff in that we did the work to collect it, and then kind of the question became, well, now what? And the well, now what is, let's find some ways to expose it. So, ma'am in the back, and sorry.
I'm sure you've heard this request before, but could we plot the earthquakes in the subsurface soon?
Yeah, great question. And I didn't cover that piece I mentioned. So we get that request a lot, and it's, again, just one of those blind spots that I think somebody missed. Sylvia Earle, she really took Google to task for the fact that we had ignored the ocean. And today I can take something like a maritime chart, drape it over Hawaii, and then dip subsurface under the water and actually see, well, maybe, there we go, and actually see what this, what the bathymetric data under the water looks like here. So this came about because of user requests. I don't know of any efforts right now to give subterranean views, but it's a request that comes pretty often. You'd be amazed it comes from like big mining companies and folks who really would love to look underground. It just wasn't kind of envisioned in the original scope of Google Earth, but possibly down the road. So great question. Sir?
I'm a little confused on the difference between Earth Builder and the enterprise that will be.
Yeah,
will have
great question.
It's
So
just that the enterprise can support more types of data, and Earth Builder uses a Google server.
yeah, so the difference today is that there's not feature parity. So you can actually, because the Google Earth Enterprise is an older piece of software, it's been around for 6 years, you can do more with it. It does imagery, train, and vector data very well. The difference is that Google is very cloud focused because that's where really kind of the power is in this distributed computing. It's using tens of thousands of processors to do interesting things with data. And so Google's investing heavily in maturing the cloud platform, which is Google Earth Builder. So for folks who maybe you have some sensitive data that you wouldn't want to push out to a public cloud, you can imagine certainly some government agencies have that sort of data. I met recently with Saudi Aramco, like the massive, Saudi Arabian-backed oil company, and they just basically said, we will never trust anybody with our data. It doesn't matter, our well and reservoir data is just absolutely, it's a national secret. So in that case, those folks are always going to want on-premise software that they can control, they can install behind a firewall, or they can completely disconnect from the world. The challenge there is it just doesn't scale as easily. With Google Earth Builder, we can throw 50,000 processors at a job, and you can have advanced imagery processing and delivery in a matter of seconds. So those are the big differences today is performance, and feature parity doesn't exist. I think feature parity will get there because there's a lot of engineering being invested in Google Earth Builder to make it support terrain. It's just, again, it's going to be hosted from Google's infrastructure as opposed to installed on your servers. So, good question. Sir?
So who owns all the data that Google has?
So in Google Earth itself, the data is licensed from, the two big ones are Digital Globe and GeoEye, was where we get our satellite imagery. We also buy imagery from Spot Image, and then we buy from about 500 different aerial imagery providers. So folks around the world who are flying small fixed wing or rotary wing aircraft, and we buy that imagery from them, or license it really. And our license is usually just to allow it to be visualized. We can't allow people to download the source data, but like with GeoEye, we have right of first refusal on all of their imagery. So we have the ability to expose it. Now, if you want to buy imagery of your farm or your business, you can go to GeoEye and buy that imagery, but if you wanted to broadcast it to the world, that's where Google gets right of first refusal. So it's kind of a sticky wicket, and it's.
What is right of road?
So you're not going to see that imagery on Bing Maps, right? So you could go out today and you could buy from GeoEye, not from Google. You could buy from GeoEye the imagery that you can use for in your business, but you're not going to see it appear on Yahoo Maps or Bing Maps because, well, just of that relationship that our folks made with GeoEye. So. But again, GeoEye owns the imagery. We've just licensed it to expose it as the only one on the internet who can expose that imagery. So, Data you upload into Google Earth Builder is totally yours. In that case, we're just the service provider. The imagery is yours. The data is yours. We are just the service provider, and you can cancel that relationship with Google at any time. Google is big on this concept of data liberation. They were the founding members of dataliberation.org. But the concept there is that you should be able to take your data anywhere you want, anytime you want to. And so with Gmail, for instance, how many of you use Gmail? How many of you use Gmail for years, right? You've got lots of good contacts and email in there. Well, wouldn't that be just a great way to just lock you into the platform and never let you go? You've got all your data, you can't go. Well, that's what Google didn't want to do, and certainly that's what other collaboration and messaging partners have done in the past. So Google spearheaded this data liberation, where at any time you should be able to take everything out of Gmail, take it with you, and go somewhere else. And that's good for the ecosystem because it forces us to stay on our game. We can't rest on our laurels, and we have to keep providing a platform that's fast, responsive, and innovative. You own the data. Take it with you when you're ready to go. Sir?
What do you recommend for, so there's a lot of GIS students in the room.
Yeah.
What do you recommend for people that maybe this seems a little bit intimidating at first? Where are they going to start? And, and then looking forward in careers, should they be signing up to these outsourcing things and working for pennies, or are there actually career options there?
Yeah, I don't think that is a sustainable model for the future. At one point over the holiday break, I really got into this side project, and we had a baby, so I had a little bit of paternity leave, and I kind of came to my senses and realized I had 17 of these people working for me. It was costing me $200 a week, not a lot, but it just kind of got addicting in the sense it was just so much. So many people were so excited to work really hard, and they were just totally bidding to do it cheap. It's a good question. This is the type of thing, if you're going to go out tomorrow and you're going to get a job in GIS at the state, local, or federal level, you should probably know the ArcGIS suite of products. That's what's going to get you in the door, because the people, the decision makers inside of that organization have used those products since they came up. Increasingly, though, stuff you're seeing with open source, stuff you're seeing with, I don't know how many of you ever checked out Mapbox, but Mapbox provides a really cool open source / freemium model. They have some premium support with a product called TileMill, which lets you make really beautiful mapping tiles, open source easily. This sort of thing is just creeping up. And if I were ESRI, or I was like a decision maker at ESRI, this would scare the heck out of me, because this is basically making beautiful map tiles for free. And it's an open source community where people are contributing code. So I think that landscape is changing. So immediate term, like in the next 3 to 5 years, know your ArcGIS products, but also be aware and exposed to what's coming up, because these products are going to change the landscape. I think ESRI is going to be there for forever. They're doing a great job of re-engineering their software, but they're at the disadvantage that in some cases they're married to code that was written 15 or 16 years ago, where folks like this come up and write a whole new architecture that can leverage things like HTML5 and all these great things we can do in a web browser today. I recommend highly kind of be active on Twitter. I don't actively tweet, but I am a total passive Twitter voyeur, in that I follow lots of GIS people, because it's really interesting to hear what they're talking about. So ESRI has a great outreach and education department. They tweet really cool things that are happening with their ArcGIS Online platform, but there's also tons of open source contributors here who are always saying interesting things about GIS, talking about conferences, linking to cool demos or cool vignettes that demonstrate a neat way to interact with data. So definitely I would recommend be engaged on these social media platforms and just be aware of what other people are doing. So that's my half-assed answer for that question. So.
Any other questions?
Sir?
So, like you said, Google focuses mainly on urban areas because that's where the large,
Yeah.
where the most demand is for it. But there's a lot of interesting high data information that can come from rural areas and environmental things.
Yeah.
Is that going to be a push? Is that higher satellite information going to come just as it gets more cheaply available, or is that going to be an internal decision where Google has to say, okay, we want to start prioritizing this and making it available?
Yeah, so I think your first point that it's all becoming cheaper and easier to acquire. So satellite imagery today, because there's competition in that market too, right? Digital Globe and GeoEye are competing for providing imagery, so they're doing more. Google's going to keep trying, right? We're going to keep trying to take as much as we can, but there's 502 million square kilometers of space on Earth, and at this point we're collecting 45 million square kilometers a year. So it's going to take us some time to ramp up. And also imagery collection is really difficult in so many parts of the world, right? In sub-Saharan Africa, where you get crazy windstorms and dust storms, in the tropics where you get maybe a couple good days of clear weather a month. There are some nuances there that are difficult. So we're going to keep increasing our velocity, but the chance we're going to have the one piece of real estate that you are interested in buying, you know, on the other side of the canyon, that's where it's hard to say, you know, because we're probably going to just acquire that image when it's available. And we're not buying imagery that has lots of cloud cover. We try to buy imagery that is taken during the fall or the spring, because that's when a lot of the foliage is missing, so you can actually see the car in your driveway. So that's where Earth Builder comes in, is we wanted to productize the platform, and that way if you had imagery that you collected from a blimp or from some new cool UAV that you purchased, you can upload that data and do something with it using our platform. So,
What do
ma'am.
we- oh, sorry.
When you notice problems with registration, is there one data source that's more reliable and more accurate than the registration and photogrammetry?
No, you know, we always encourage you to report a problem, so it's easiest to do from maps.google.com. Well, not necessarily there. Is, you know, if you find an area that doesn't look right or needs to be corrected, you can pretty easily report a problem. I'll try to show you where that is here. So right on the bottom here, report a problem allows you an interface where you can tell us, hey, this business is in the wrong place. You got road or street that's miscategorized. In your case, you could say, come here and say you did a terrible job georegistering this image. It's feedback we'd love to have, and that goes into our system of, it's one indicator that we use to kind of recorrect and revector as we go down the road. So.
I mean, I've always sort of been concerned reporting a problem, you're sort of throwing something over the fence, you don't have any notion that anybody's actually going to read it and take any action. So that's sort of a barrier to me reporting, because you go around and you see that things are mislocated quite often.
Yeah, and that's very fair feedback, and I think we're looking for more ways to be transparent about that. It just turns out that it's really a difficult thing to do, because even there's new legislation called CAPA, which means that like if anybody under the age of 13 ever puts anything in your software, their parents have to be able to take that data out at any given time, and even like little constraints like that you wouldn't think are challenging present massive problems for a company like Google, because now all of a sudden we have to associate an error that was reported with who reported it, and we need to be able to pull it back out, and it could possibly be subpoenaed. And so there's sorts of legal constraints and policy constraints that nobody envisioned when it was a smaller company that have now come into play. For the most part, though, I'll tell you that this just becomes one indicator. This is a report, and our system in the background is always kind of rejiggering and reconfiguring all the imagery we put in. And so it'll take a report like this, and it'll start to say, well, do I have a street? Can I recognize there was a street there last year? Was there a street there the year before? It'll try to use a bunch of other indicators like databases we buy access to, like the old Yellow Page databases. It'll try to use open searching on Google to try to cross-reference. So this just becomes one indicator, and that's part of the reason I think we are not as transparent, because it's one indicator, but we might use 199 other pieces of data to corroborate or discount what that user told us. So it's not as simple as, hey, this user said the street was wrong. We don't necessarily have just a person look at it, say yes, they're right, and then attribute the data. It's kind of much more involved process. So that's the best answer I have, unfortunately. MapMaker is another cool thing. And again, controversial in some ways, because again, you're just throwing data at Google. But MapMaker is your ability to go out and make changes to Google's base map. So for instance, there's areas where we just don't have any coverage. Villages in Pakistan, remote villages in India. Folks will come on and actually draw their street, label their street. And this is a fun website if you just want to waste time on a Friday afternoon. Google.com/mapmaker/pulse will show you some of these edits being made in real time. But 10,000 times an hour, somebody's coming onto a Google map and actually drawing a physical feature and telling us we got it wrong, or hey, they built a new subdivision. Because ultimately, it's just hard to stay on top of those data sets. It's just, stuff is changing all the time. So, all right.
So for those of you that are in this afternoon's lab, Sean's going to be joining us out there. For the rest of you, if you want to chat with Sean a little bit, we've got a few minutes until that lab, and then we'll be out in the quad if you want to try and catch him there. So let's give Sean a big thanks.